I received this question from a student about question number 8 in the balancing equations worksheet. And it's just about how you balance an equation when you have, for instance, oxygen here is separated between two different compounds. So I'm going to show you how you work with that, and also looking at when you have a coefficient that is not a whole number. So you can work with coefficients that aren't whole numbers, but in the end, so in other words a decimal, but in the end you have to simplify it into a whole number at the end. So you can, in the interim, use decimals, but make sure you fix it at the end. So I'll show you what that all means. So first of all, what I've done here is I've got C4H10 plus O2 on one side and CO2 plus H2O on the other side. And I need to balance to make sure that the carbons on both sides are equal, the hydrogens on both sides are equal, and oxygen. And notice how I list my elements. If you're following the rules of balancing, it always works best if you do the non-metal elements first, then your metals, and then leave hydrogen and oxygen to the end. So that's the way I've set it up here. So my preliminary count of carbon on my left side is 4, my hydrogen count is 10, and my oxygen count is 2, and this of course is based on my subscripts. And then on my other side, I'm going to have 1 carbon, I'm going to have 2 oxygens, but in terms of, 2 hydrogens, but in terms of my oxygens, you can see they're split between the 2 compounds. So I have 2 oxygens here, I have 1 oxygen here for a total of 3 original oxygens. Now what I need to do is I need to balance this out. So I'm going to balance first my carbons. So if I have 4 carbons on my right, then if I put a coefficient of 4 here, that should balance out my carbons. That's going to give me 4 carbons, but it's also going to change the number of oxygens I now have. So 4 times 2 gives me 8, plus my 1 here means that my new total is going to be 9. And I like to list it like this, where I start off with my originals and then I put a scratch through my original and then show the next one, because that shows my steps and how many times I had to go back and forth to balance. Now that I have my carbons balanced, the next thing I'm going to balance is my hydrogens. I have 10 on my left, so I need to balance on my right, and so I'm going to put a coefficient here that's going to create 10 hydrogens on my right. So that's going to be 5, because 5 times 2 gives me the 10 that I need. And remember, you can only change the coefficients, you can never change the subscripts. So 5 times 2 now gives me 10 hydrogens, but that's going to change my number of oxygens, because that 5 also has to be applied to my oxygen. So 5 times 1 is going to give me 5, plus the 8 that I originally that I have here. So 4 times 2 is 8, plus the 5 is going to give me now 13. So I now have 4 carbons, 10 hydrogens, and 13 oxygens. So I now have my carbons are balanced, my hydrogens are balanced. Now I need to go about doing my oxygens. If I have 13 oxygens on my right and only 2 oxygens on the left, this is where I can now use a decimal as a coefficient, just to help me with my balancing. I can't leave it as a decimal because coefficients aren't to be decimals, they're to be whole numbers, but in the interim I am going to use a decimal. So the coefficient I'm going to put here is going to be a number that when I multiply it by 2, it gives me the odd 13. So that means that I'm going to use 6.5 as my interim coefficient, and that's going to change this to 13. And nicely, I now have balanced all of my elements. But as I said, I can't keep that 6.5. So what I'm going to do is I'm going to multiply 6.5 by a number that's going to create a whole number. And in this case, if I multiply 6.5 by 2, I will get 13 in front of my oxygen. And 13 oxygens times 2, or 13 times 2 for my coefficient here of 13, that's going to give me a new count of 26. But before I go ahead and do that, when you fix a decimal coefficient by multiplying it by a number, whatever you multiply by, you must also multiply the other coefficients. So I'm going to go 2 times this one here, which is 1 actually. We didn't put any coefficient in front of that. We didn't need to. We assume it to be 1, but now we have to multiply that by 2. I'm also going to multiply the coefficient of 4 by 2, and I'm going to multiply the coefficient of 5 by 2. So my new coefficients are going to be 2. I've already done 13 in front of the oxygen. This becomes 8, and this one becomes 10. So my new formula is going to be 2C4H10 plus 13O2 becomes 8CO2 plus 10H2O, just to clean it up a little bit. Now what we need to do is make sure that everything balances out. So now that I have my new coefficients, I'm now going to do my counts again. So I have 2 in front of C4H10, so that means that my new count for carbon is going to be 2 times 4, which gives me a new count of 8 there. And then my hydrogen count on my left side is going to be 2 times 10, new count of 20. And then I have 13 in front of my oxygen, so 13 times 2, and I had already done that, is 26. So my new count on my left is 8, 20, and 26. And now I need to do my other side. So on my other side I have 8 in front of the carbon, so my new count for carbon is going to be 8 on the right side. And then my hydrogen is 10 times 2, which gives me 20. And you can see that I'm starting to, they're equaling out, so it's looking good. And lastly, let's look at oxygen. I have 8 times 2 gives me 16 oxygens here. And then I have 10 times 1 for 10 oxygens there, which will give me a total of 26 in the end. And you can see now that I've got both sides are equal. So this equation here with my coefficients of 2, 13, and 8 and 10 does balance out both sides of the equation. So I hope that helps with question number 8 on the balancing equation worksheet. Thank you for watching.